In this video, we want to study the intervals of increase and decrease of functions. And in this example here, we have an example here, f of x equals to x to the power 3 or x cubed minus 3x plus 2. At our first step, we're going to first of all take the first derivative of the function, right? It's going to give us f prime of x, which is equal to 3x to the power 2 minus 3. In second step, we want to find the root, or we want to obtain the roots of this first derivative, and this will be by solving the equation f prime of x equals to 0. This means that we're going to have 3x to the power 2 minus 3 equals to 0. We can factor 3 run out. It's going to give us x to the power 2 minus 1 that equals to 0. And this here is a perfect square that we know. It is 3 factor x minus 1 times x plus 1. This means that our two solutions of this equation here will be x equals to 1 or x equals to minus 1, and these are two roots of this first derivative. Of course, here 3 as a factor x minus 1 times x plus 2, so that's minus 1 because the result is here minus 1 and this one is it. So these here are our zeroth root of the function, these two right here. Okay, and a third step, okay, we're gonna form an open interval with the zero root, and of course the point of discontinuity. I mean, if we have some here, any here or something like that. So this is here our open intervals with the zeroth root of the first derivative, and the point of discontinuity, because the function here is coming with a value changing, becoming 0, becoming 0 and then changing and take another value. So with the point, the function is discontinued at this point here, minus 1 and 1. And our fifth step will be 1, 2, 3, the fourth step. Okay, the fourth step. Now we would take a value from every interval here, minus infinity to minus 1, minus 1 to 1, and 1 to plus infinity. Take a value from every interval here and find its sign in the first derivative. So let us just take away here minus 2, minus 1. Let us take, for example, minus 3, right? So in the first derivative, this one here, it's gonna give us f prime of x, f prime of x of minus 3, excuse me, f prime of minus 3. This is the value in between minus infinity and minus 1 equals to, so we have in here 3 times minus 3 to the power 2 minus 3, and minus 3 to the power 2 is 9 time 3 is 27. 27 minus 3 is 24. And this value is positive. It means that the function in this interval is increasing. Okay, so we will put like maybe a plus here to mean that the function is increasing in this interval here. And we're going to take another value in between an interval of minus infinity, minus 1 to 1. What about 0? Of course, f of 0, yeah. F of 0 would be 3, 0 to the power 2 minus 3, and this is 0. This is going to give us minus 3, and minus 3 is less than 0. It means that in this interval the function is decreasing. In this interval the function is decreasing. Okay, we put a minus there to mean that the function will be decreasing here. And in the interval of 1 to plus infinity, we can take like f of 2. Why not? F prime of 2 is giving us 3 times 2 to the 2 minus 3, and this is 412 minus 3, it is 9. Okay, this is giving us here 9. and 9 is positive, is bigger than 0. So the function will be increasing in this interval right here. Okay. Now in our last step, we can write the interval of increase and decrease. So this is what we got here. We say that the function will be saying that increasing is the green letter, put in green. Okay, put here increase or increasing. Increasing. This is going to be the interval. Let us just put it like this. This is going to be the interval, open interval, minus infinity to minus 1, and from 1 to plus infinity. Oh, sorry, from 1 and 1 to plus infinity. In this interval, the function is increasing, and the function is decreasing in the interval of 1 and minus 1 included. Minus 1 and 1. The function is decreasing in the interval. We can even draw the sketch the curve of this function. So now we're having an x-y coordinate here, and we're going to have a table of values here to find the different value of component of our function, different point on the function. So when we're going to plug this. This is the input and this is the output. We're going to input this here in the function, original function, to see what the output on the y-axis will be. An xy coordinate, we're going to and table of values with an input and an output. So we're going to input this value in a function, original function, and see what the output y will be. So we can plot the graph. When x for x equals minus 2, we input in the function here. It's going to be minus 8 plus 6 plus 2. This is going to be 0. We're going to have 0. So for x2, we're having y 0. So this is at this point right here. For x minus 1, we're going to have minus 1 plus 3 here plus 2. This is 5 minus 1 is going to be 4. For x equal minus 1, we're having 4 right here. Okay, and for x equal 0, okay, then let me just put a value here. We have it here 0, we have here 4. For x equals 0, we're having 0 0. Y will be 2. It means right here. So we're getting 2 here, and for x equal to 1, we have it here 1, and minus 1 plus 2, this is 0. 1 is 0, so we're going to put here a 0 at this point right here. And for x equals 2, we have in here 8 minus 6 will be 2 plus 2, 4. So for 2, we're having 4 right here. Okay, so we can draw we can even continue, right, doing like minus 3 or some stuff like that to see what the function. So this is what we said. We said that between, let me just draw that with the color, appropriate color, from minus infinity to minus 1, from minus infinity to minus 1, the function is increasing. Minus 1 is here, so the function is increasing right here. Okay, so this function is coming this way, and until here, increasing. This is our function increasing this way right here. Okay, and in an interval of minus 1 to 1, the function is decreasing to here. So the function is going that way down, dropping down here until minus 1, until 1, pardon, until 1. Okay, and the interval of 1 to plus infinity, the function is increasing. That's what we have. So the function is increasing here. Okay, and that's our function. I mean, it looks like an n, but it's not an n. It is a function It's not that, I mean, I'm not that good at skating, but well, I'm trying my best. So this is just like this. Okay, so let me just focus a little bit. Okay, that's how the function looks like, right? So again, to study the inverse of increase and decrease of a function, you first need to take the derivative, I mean the first derivative of the functions, right, of the function. If you got functions of the function, first of all. Secondly, you have to find the zero root of the function by, you know, working out by solving this equation f prime of x equal to 0. And then you can draw an upper interval and take value and value in every interval to define, I mean to see how the function or your curve is behaving. Okay, and that's what we did here. We had here 24, and 24 is positive in this interval. It's minus 4 minus 3. This is an input minus 3, and we have 24 as output. And we took 0 and 0 as 0 was the input here, and the output was minus 3, and minus 3 was negative, and it means that the function is decreasing in this interval. And we had f of 2 as input. We have 9. 9 is positive. It means that the function was increasing in this section right here. So, and after you do that, you can write, the interval of decreasing or increase, of decrease of increase, right? The interval here increasing, we're having here from minus infinity to minus 1, and from 1 to plus infinity. And the function is decreasing in this section, minus 1 to 1, right? And then you can plot the function and draw the function. Yeah, you don't really need it, but as soon as you have the interval, everything is done. The work is done. Okay. And we've also seen here the function was having a point of discontinuity at its 0 point. What does that mean? It means that what you can look at the graph here, where the function is increasing here, is having the plus sign as a positive sign. When he got here, he turned, I mean, at this tangent here, and changed its sign, so it gets discontinued, and do the same thing here. That's what we did here. This is a point of discontinuity of the two functions, of this function right here, minus 1 and 1.